Hello, and welcome to Invitation to Puzzles, the series where we try to welcome you to the exciting and cool, in my opinion, world of all sorts of puzzles. So, we've talked about Sudoku, we've talked about pencil puzzles. Today we have a Sudoku puzzle. And so I'm trying to go through some of the, I don't know, common variants, if you will. So, Arrow is one of the variants that you'll see most often popping up in Sudoku. So I want to talk about that today. I realized while I was sort of looking for puzzles for this series that at some point in my past, about a year ago for a course I was teaching, I made example puzzles of a bunch of the common variants that I had done. And so I thought, hey, if those are puzzles that I was trying to make for purposes of introducing people to these, maybe I should do those. So technically I made this puzzle, and you'll see a few more of these popping up in the series at various points. I don't know how much, if at all, that sort of discourages people from wanting to do it, or maybe people will be excited because they can actually they can do the puzzles and maybe they'll enjoy them because these haven't really been published elsewhere. So there is a link down below if you just want to do the puzzle and try it out. Let me know if people do really like these. I can do more of them and I can make more puzzles for it to try and sort of introduce various things. I also have a bunch of 6x6s, which I haven't done yet, but I might do some of those on here as well. But anyway, this is the first one of my puzzles I'm recording anyway. We'll see. So how does an arrow puzzle work? So first of all, we have normal Sudoku rules. So that means that we need to contain the digits 1 through 9 in every row, column, and box exactly once each. But then the arrows, what they mean is that the digit in the circle is the sum of the digits along the arrow. So for example, I could make this 7, 2, 3, 2, and that would be a perfectly valid fill because 2 plus 2 plus 3 is 7. You've probably seen, and I think we've done previously at various points in this channel, killer puzzles. Where there's this rule in a killer puzzle that things can't repeat. There's no concerns about repeating digits. You can repeat digits as often as you want within an arrow puzzle. Okay, so all we have to do is make that work. I should note here is an arrow that has 2 arrows pointing out of it. What this you should view as being 2 arrows on top of each other. So these 2 digits sum to that digit, and these 2 digits sum to that digit. So I could do something like 3, 1, 2, 1, 2 would be a valid fill for this arrow, just so that we're clear what happens. Okay, so let's have a look at this grid. So a tip, at least for puzzles that I make, is that quite often the best place to look is in box 1. We also have our lone given digit here. And so one of the biggest constraints in arrow puzzles is that if you add a bunch of digits together, like here we're adding 3 digits together to get this digit, intuitively, that's going to give you a pretty big number. And this number can't be that big, right? Because it's a Sudoku digit. So it's at most 9. And so if you have big, long arrows, you can ask yourself sort of like what the smallest I could possibly make this circle is. And normally that would be 1, 2, 3, which would be 6, which would mean that this digit's always at least 6, 7, 8, 9. But actually, owing to this given 1 here, it's actually more than that, because actually the minimum that I could put here is 2, 3, and 4. And so that adds to, in fact, 9. And so I can't possibly do anything other than 2, 3, 4 here, because say if I take the 4 off and put a 5, this already sums to 10, and I can't write a 10 into that cell. So in fact, these digits have to be 2, 3, and 4, and then this circle digit here is a 9, which is the sum of those. Okay. Now, these 2, 3, and 4... they are the digits 2, 3, and 4. So they're a triple if you want to think about it in terms that we've used before, which means that these digits here, they can't be 2, 3, or 4, or 1, or 9. So these digits here are from 5, 6, 7, 8 only. Okay, and that puts some pressure on this arrow already. So first of all, we can say this circle, and this is true of every arrow, the digit in the circle has to be bigger than every digit along the arrow, unless the arrow is length 1. So for example, I could never put an 8 here, because the 8 would make this smaller, and I could never put a 5 here, because this would need to be smaller than 5. So we got that this is 6, 7, or 8. This is 5, 6, or 7. But it's maybe worth also asking about these two cells, because actually, again, let's ask the question, what is the smallest number that this arrow could possibly sum to? And so here I don't know anything about these two cells, so the smallest they could possibly be is 1 and 2. If you want, I know I couldn't put the 1 there. But their sum at minimum is 3. So actually the minimum sum this arrow can have, if I look at it, is 5 plus 3, which is 8. And so just like this had to be 9, because that was the smallest it could be, this has to be 8, because that's the smallest it could be. But now that 8, remember, only worked in the exact universe where this was 5 and these were 1 and 2. And again, so we have to, if the minimum value this can be is 8, we have to minimize everything. And so now the Sudoku gives us that this is a 2 and this is a 1. Okay. Now, this arrow has become interesting because I now know it doesn't have a 1 or a 2 on it. So usually 2-cell arrows are a lot less powerful than 3-cell arrows. That is, just this is a 2-cell arrow because there are only 2 arrow cells on it. But now the smallest numbers I can add here are actually 3 and 4, which would give me 8. Sorry. I should probably remove math from my screen name. 3 and 4, which would give you 7. However, there's a Sudoku problem with that minimum. This isn't actually the minimum. And there's a couple ways you can see this, and I'm going to show you 2 different ways that you can think about this. So I'm going to show you what happens here, and you can choose which of these you like better. Okay. So here's method 1. Method 1 is... if I actually did say, okay, the minimum here is a 3-4 pair with a 7, that creates an issue because now that 3-4 looks over. And that would make both of these digits a 2. This would be a 3-4 pair, making this 2 plus 2, except that would repeat 2 in the row. Or if you want, you can think about this as, oh, this is 4 cells in the Sudoku, but they only have 3 values they can be. They can only be 2, 3, and 4. So actually, this is not the minimum. Actually, the minimum is 8. And then, because it can't possibly be 9, because there's already a 9 in the row, and so this is 3 plus 5. Okay, and so that's one method. But in case you didn't like that, as I suspect some of you may not have liked that, then we can ask ourselves, okay, what is the minimum that this can be? It's 3 plus 4 is 7. What's the maximum this arrow can add to? Well, the maximum this arrow can add to is 8 because 9 is gone in the row already. And so now what's the largest number I can possibly put here? It's going to be a 5 because I could do 3 and 5 here, and that would sum to 8. If I put a 6 here, that's already too big, right? If I put a 6 here, 6 plus 3 is at minimum 9. Okay. And so from this point of view, what you spot is that these 4 cells actually form a 2, 3, 4, 5 quadruple. Okay, and just to walk you through what that means there's a set of 4 digits, 2, 3, 4, and 5, and all the yellow cells are from those 4 digits. They're all from 2, 3, 4, and 5. And so since 4 cells need 4 different digits in them, that means that actually these digits have to be 1 each of 2, 3, 4, and 5. And if that's the case, well, then we know, for example, we know a couple things. One of the things is we know these aren't 2, 3, 4, or 5. So these are 1, 6, 7, 8. Okay, so that is one thing that we know. We can think about that later. But I can actually do one better, because since this is a 2, a 3, a 4, and a 5 in some order, well, where's the 5? Well, the 5's not in this box. Neither of these cells can be 5. So the 5 has to be on this arrow. But if the 5 is on this arrow, then this arrow needs to be summing to 8, because I can't make 2 plus 5. That's not a valid combination. So this needs to be summing to 8 with a 3, 5 as my pair. And if these digits are 3 and 5, that means neither of these digits can be 3, because that's a 3, 5 pair. Again, just to mention, since I'm using this notation, I should mention the corner mark means the 5 here that's corner marked means one of these two cells has to be 5, because neither of these can be, and these 4 digits have a 5 in them. And so that 5 means that these are actually 3 and 5. That's a pair, which means these digits are actually 2 and 4. And now that 2 and 4 is actually a pair in box 1. So that makes that digit a 3. And as you can see here, by the way, this is in the settings. If this is not on by default, there's a conflict checker is what is highlighting in red that I already have an 8 here. So none of these can be 8. That is what is happening there if you are trying to figure that out, if you do not have that enabled in your version. Okay, so we've got all of that. We can now look at this combination of cells, which, and sorry, I should say this first. You could have done this either way. Either way you looked at this got you here, that this had to be a 3, 5, and an 8. Either you looked at this and said these really can't be 3, 4, and 7, or you said, okay, there's two possibilities. It's 3, 4, and 7, or 3, 5, and 8, and that gets me a quadruple that I can then investigate, and upon investigating it, you get here. So I went through that 2 different ways. Depending on how your brain works, you might like one of those more than the other. Okay, now let's look at these 3 cells, which are 1, 6, and 7, because we've used all the other digits in the row. Okay. Observation 1, this definitely isn't a 1, because I can't make these 2 cells, one of which would be a 6 or a 7, add up to 1. Secondly, I can't make this a 7. That's for sure, because if this is a 7, now I'm making, and 7 plus something equals 6. I'm not allowed to use negative numbers in at least this puzzle. But there's a somewhat tricky thing here, which is that this can't be 7 either. Because if this circle is 7, what's going to happen? Well, if this circle is 7, now these two need to add to 7. One of them's a 1 or a 6. Well, 1 and 6 add to 7, so the other one's a 1 or a 6. Except that's a problem, because now I've got 1, 6, and 7 in the box, but this cell is also from 1, 6, or 7. So because of the exact way these numbers here lined up, this digit can't be a 7, because it would break this cell. It would force these to be 7, 1, 6, which would leave this cell with no value. So that's not what happens. Instead, this is a 6, and then just chasing our pencil marks, that's a 1, and that's a 7, which then means that digit's a 5, owing to the fact that it needs to add to 6. Okay, so we have all of this now filled in. We can ask ourselves now a little bit about what these digits are. And so if you're new to this, you might do this by just filling all of these in. You might fill in 2, 3, 4, 8, 9 are these digits. And then you might think about which of these cells can really be which digits. Or if you prefer, you might also just think, okay, what digits do I have looking at this box by Sudoku? And so I've got in this row, I have a 1. Well, that's not very interesting because I already know where the 1 in this box is. I've got a 5. Well, I already know where the 5 is. I've got an 8. So that means one of these 2 digits is an 8. And I've got a 2, which means one of these 2 digits is a 2. And that means that these 2 digits are 2 and 8. Okay, and so there's this, how are the 2 types of pencil marks related game. So we've got the center marks, which says what the cell can be, and the corner marks, which say where the cell or where that digit can show up. Well, the 2 and the 8 definitely show up in these cells, but it's only 2 cells. So I know the 9 doesn't show up in any of these cells, for example, because if I put a 9 in here, then I need to make 3 digits appear in these 2 cells, 2, 8, and 9. That doesn't work. And so what happens here is when you have overlapping corner marks like this, so I've got 2 cells with overlapping 2, 8 corner marks that can only go in 2 places, these sort of upgrade to center marks if you want. So these are 2 and 8. And then these down here are the remaining digits. So then these are 3, 4, and 6. No. 3, 4, and I swear there's another digit in there. 3, 4, and 9. Okay. These are 3, 4, and 9. So that's sort of one approach. That's probably how you do this if you had done a lot of these, but it's totally fine if you want to just sort of, for your sanity, say, okay, I'm just going to say, okay, I know that I know a lot about this box. I don't recommend doing this in a random box, but this box we know a lot about because there's arrows in it and there's a lot of digits looking at it by Sudoku. So you can say, okay, so the digits left are 2, 3, 4, and 8, and 9. Okay. You can take out your things that things definitely can't be by Sudoku. And then what you would see if you did that, rather than seeing this sort of 2-8 pair that we found before, what you'd probably spot is this 3, 4, 9 triple. And so this 3, 4, and 9 need to be the 3, the 4, and the 9, because it's 3 cells that can only be from 3 digits. By the way, I can get rid of this yellow, I suppose. And so that means these 2 digits can't be 4 or 9. And so notice that gets you back to exactly the same place. Either way is totally fine. Now, there's a bunch of other things you might also notice. So, for example, you might notice that you could never place a 9 here, because if I place a 9 here, that is going to make me make this arrow add up to something that it just can't. So I won't do that. Basically, you can never put a 9 on an arrow of length more than 1. Because that would make the total be more than 9, and you can't write a number that's more than 9 in a circle. Okay. Another thing you might notice is that this cell can never be 2, and you might notice that for a couple of different reasons. One reason is that I've actually made it more apparent by pencil marking this box first. Namely, this 3 or 4 is going to be added to something and give me this number. Well, there's nothing I can add to 3 or 4 and get 2, at least out of Sudoku digit land. But also, this could never have been 2, because the minimum sum of these 2 cells was always going to be at least 3, because they have to be at least 1 and 2. And if you actually even think harder, this one can't even actually be 1 or 2. So actually the minimum sum of these was going to be 4. So this was just never going to be 2. So that means it has to be 8. That has to be 2. Okay. One of my personal favorite tricks is now to do with this arrow. But anytime you have something like this filled in where you've got all but one cell sort of marked on an arrow, you could ask yourself what this cell is going to be. Because if I think about it, this is going to be either a 3 with a 5 or a 4 with a 4. Except the 4 with a 4 version has problems, which is that if I do the 4 with a 4 version, then I'm now putting 2 4s in column 7, which I am manifestly not allowed to do by the rules of Sudoku. And so, in fact, actually, once you actually examine the possibilities and look at what all of these pencil marks mean, this actually has to be a 3 with a 5. Okay, and so we end up with something looking like that. Okay. So, now we can look at this box, I suppose, is where we're sort of being led by our process here. And so the thing about this box to notice is that it's got a lot of arrow cells in it. And arrow cells want to be small. And so there are, as I keep saying, there's a couple different ways to think about this. But the first one I'll point out is that if this is a 4, things are going to go horribly off the rails very quickly. And I'll show you why. If this is a 4, then these digits are a 1 and a 3. Okay, that doesn't seem so bad until you think about what this arrow is. And namely, what would this arrow have to be? Well, at minimum, this arrow would now be 2, 4, and 6. Because there's already a 5 in the box. Well, 2, 4, and 6 actually couldn't even be 2, 4, and 6 because all of those are up here. So at minimum, it would be 2, 4, and 7. Well, those numbers add to 13. And so if I use both the 1 and the 3, then I just completely break this arrow. I blow up the total and the minimum becomes way, way, way too high. And the reason why this should be a little bit intuitive to you is I know I want small numbers on this arrow because I need to add 3 numbers together to make this circle work. And using a 1 and a 3, which is the only way I could make 4, uses a lot of those small digits. So I think it's relatively intuitive to ask yourself, once you sort of have this in your mind, can this really be 4 because of what it would do to this? There's a fancy way to do this as well. And so let me also show you the fancy way to do this. And then I'll sort of split the difference and I'll give you the medium fancy way to do this. So here's the very fancy way to do this, is to look at these 5 cells together. And so these 5 cells together, what do they sum to? Well, rather conveniently, I know these 2 sum to this number and these 3 sum to this number. And so what that means is that these 5 cells together have the same sum as these 2 cells. Okay. Now, how is that at all helpful? Well, I can ask myself what the minimum sum of these 5 digits is. And if you think about just the minimum, it would be 1, 2, 3, 4, 6, because we've already got the 5. Okay, and these numbers sum to 16. That's the minimum. So the minimum sum the 2 green digits could possibly have is 16. Well, that means the green digits need to sum to at least 16. Well, that tells me this can't possibly be a 4. And the reason why I'm saying this can't possibly be a 4 is because then in order to get these to be a minimum of 16, I would need this to be at least 12. Well, that doesn't work. If these 2 digits need to sum to a minimum of 16, then I need these to be a minimum of, if you think one of them is a maximum of 9, this is a maximum of 9, therefore this one is a minimum of 7. And so therefore it is 9. Okay. So that's a different way to think about it. Just for slight overkill, let me show you one more trick that you can internalize if you like, which is that if you have a length 3 arrow like this, and you think about the digits on it, there always have to be 2 digits on it from 1, 2, 3, as long as the arrow is completely contained in a row, column, or box. That is, as long as there's no repeated digits. So there's always at least 2 1, 2, 3s. It could normally be 3 1, 2, 3s, but it needs at least 2 1, 2, 3s. And that's because if it doesn't have at least 2 1, 2, 3s, then the minimum it could possibly be is a 1, and then the next 2 digits would be a 4 and a 5, and that's already 10, which is too big. So that's sort of a natural way of sort of splitting the difference here, so you don't have to do so much math when thinking about this. Is that just if you have a length 3 arrow, you can always ask, okay, I know there's going to be 2 1, 2, 3s on it at least. Where are they and what are they? And the reason why I say that that is useful here is because that also tells me this can't be 4. Because if that's 4, that burns 2 of my 3 1, 2, 3s on the 4 arrow. And then this arrow now can't possibly sum to a legitimate number. It can only have 1 of 1, 2, and 3, namely 2 on it. Okay, so that's 3 different ways that one can think about this. But in any event, the upshot of this is that this digit is a 9. And so maybe we ought to think about what digits we can put on this. Because there's only 4 ways that I can make 9 as a sum of 2 digits. One of them is 1/8, which does not look like it would be a problem. One of them is 2/7, which would very much be a problem. One of them is 3/6, which would be a problem. And one of them is 4/5, which would be a problem. So just to write those down, it's 1/8, 2/7, 3/6, or 4/5, except what we just said is it's not any of those. Because that one sees a 5 by Sudoku there, a 2, and a 6 by Sudoku. So the only thing that this can be is 1/8. Okay, so this arrow has a 1/8 pair on it. And that, again, going back to box 1, if you think about it, now makes me wonder what's going on with this arrow. In fact, actually, if you remember, the exact calculation we did as the first step of the puzzle was that if I don't put a 1 on a 3-cell arrow, the minimum thing it can be is a 2, 3, and 4. Well, this is an arrow that's 3 cells that can't put a 1 on. The minimum it can be is 2, 3, 4, which is 9. And so that actually forces that as well. We get a little bit of pencil mark clearing from that. Getting that. And let's see, what are these digits? So we've got 1, 2, 3, 4, 5. So these are 6, 7, and 9, if you like. Okay. So we can run that whole argument that we just ran backwards. If a 3-cell arrow doesn't have a 1, we've seen twice in this puzzle, it has to be a 9 with a 2, 3, 4. Well, that tells me something about this arrow. Namely, this arrow has to have a 1, because if it didn't have a 1, it would have to be 2, 3, 4 with a 9 here. Except it can't be 9 because it's got a 9 looking at it. So there has to be a 1 somewhere along this arrow. It's not in the circle, of course, for lots of reasons, including Sudoku and absurdity. So one of these 2 cells, what I've learned, is 1. Again, if there were no 1 on this arrow, it would be at minimum 2, 3, 4, sums to 9, breaks this circle by Sudoku. Okay. And so again, the corner mark here just means one of these 2 things is 1. And the reason why that's useful is because it tells me the 1 in row 4, it's not over here, it's over here. And so usually people will use a phrase like look at, namely this 1 looks at this cell, basically telling me I already know where the 1 in row 4 is. Roughly, this can't be the 1 in row 4, or it would be a second 1 in row 4. So in fact, that is an 8, and that is a 1. Okay, so what is this circle then? We've thought a lot about the minimums of various things. Well, the minimum here currently, as best I can see it, is 1, 2, and 3, which add to 6. Okay, and that guarantees that this circle is a 6 or a 7 in terms of the digit that's actually going to go on it. So that is interesting in and of itself. Okay. I can fill in something about these digits now if I want. Namely, I can write in what these digits could possibly be. So the minimum was 1, 2, 3. I could go up to 7, so that means I could make them 1, 2, 4. But these digits always include a 1 and a 2. What I'm using there is that if I want to make 7, the only way I can make 7 is as 1 plus 2 plus 4. If you try and do anything else, if you try to not use a 2, say, then you're already too big because you'd already be at 1 plus 3 plus 4. So 7 is actually only doable in exactly one way, and that way involves a 1 and a 2. Okay, and the reason I point this out is because this cell can't be a 1 or a 2 by Sudoku. And so therefore these two digits, they have to be 1 and 2. And then this digit is a 3 or a 4, depending on whether this is a 6 or a 7. Okay, so that is a 1, 2. You could call this a hidden pair, is what this is often called as, is I know I need a 1 and a 2, and there's only 2 places for them to go. Okay. I see also that, actually I see a few things. Let's look at this arrow first. This 1, 2 hidden pair actually does a lot for this arrow, because it tells me the minimum that this arrow can possibly have when it is 3, 4, which means that this arrow sums to a minimum of 7, except this circle can't be 7 or 9. So when I say a minimum of 7, in fact, there's only one thing it can actually be, which is an 8. So this circle is an 8. And now these two actually need to sum to 8 without using a 1 or a 2. And if you think through your options, that's 1, 7, 2, 6, 3, 5 is the only option that works. But here it's worth really remembering, we have a 2, 3, 4 triple in row 6. So that means the 2, the 3, and the 4 over here, this can't even be a 3. This is actually a 5. And that is a 3, is the only order we can make that work. And that means that these for the column are a 2 and a 4, it would seem. This arrow is actually kind of interesting because it can't have a 2, 3, 4, or 5 on it just by Sudoku. We've ruled off the 2, the 3, the 4, and the 5. And so what that means to me is it had better have a 1 on it. Because if this does not have a 1 on it, then its minimum actually is 6 and 7, which happen to sum to 13, which is way bigger than the largest digit I can put in the circle. So there has to be a 1 on this arrow, or it sums to too much, because, again, I can't use the 2, the 3, the 4, or the 5. Okay, well, I know where the 1 is, actually, so I would sort of corner mark the 1 like this, and then I would see, oh, aha, this is red, so then I'd go ahead and I would put a 1 here. Okay. Then I can think about what this digit can actually be, and so it's bigger than 5, so it's at least a 6. And it can't be larger than 7, actually, because if this were an 8, that would be a second 9 for the box. Okay, so this is 6 or 7. That is 7 or 8. For whatever that is worth. Now let's look at this row now that I've filled that in. Because this row, I know basically where the 1, the 2, the 3, the 4, the 5, and the 9 are. So that means the only things left in this row are 6, 7, and 8. And this one can't be 8. Okay. And the reason I filled that in is to hopefully point out, these are the 6 and the 7. In other words, this is the only place in this row 8 can go, because we've got a 6, 7 pair. So that digit is the 8. And now these two digits sum to 8 without being 3, 5, because there's a 3 looking down, and without being 2, 6, because there's a 2, 4 pair over here. And so the only thing that these can be, if they're not 3, 5, or 2, 6, is 1, 7. So we can fill in that 1, 7, and that will sort of percolate up here a little bit, giving me all of these various numbers. Okay, now this box and this column, we've made a ton of progress on. So this box, we need a 4, and the 4, notice, has to go here. And we need a 9, which has to go here, which makes that a 6 and a 7 and a 9, sort of bouncing back over, which makes that an 8 and a 7, a 6 and a 7. Okay, and now remember, now that we filled this in, that needs to be a 4 to make it so that math works. And this column now only has one digit left in it, because we've got the 1, the 2, the 3, the 4, the 5. It looks like the 6 is the missing digit. And if I look now at this digit, well, what's this digit possibly able to be? Well, it's not a 1, because the 1 in this box is over here. And it's not a 2, because the 2 in this box is over here. So this digit is therefore, at a minimum, 3. However, it can't be any bigger than 3, because if it was, these two would sum to at least 10. So that doesn't work. So in fact, we get to sort of say the minimum this arrow can be is 9. And so it is 9. So we get our 3, 6 over here like that. Okay, that leaves me with a couple digits in here. I might as well write in what they are. They are 5 and 9, it would seem. Okay. It's probably worth investigating some digits now, because I notice I've got a lot of the 9s in the grid. And so anytime you've got a bunch of a digit in the grid, you might just sort of sketch where those digits see. Like that. And so, for example, I see that in this box, the 9 can only go here. And in this box, I guess the 9 could go in either of those two places. So maybe that's not so exciting. Let's see. Is there anything else? If I look at this box, look at this box here, I can see the 4 is looking across, which is making that a 4. And if you don't want to look that way, I find that that's unintuitive for some sort of newer solvers. You can also do this way by saying, okay, this box is missing a 4, 6, and 7. Oh, look, this is a 6, 7 pair, and therefore that's a 4. So anytime someone sees something by saying, oh, this is the only place 4 could go, you could equally well see it with enough aggressive center pencil marking. So I think usually sort of as you become more experienced, you tend to want to pencil mark a little bit less. But as you're learning, by all means, pencil mark all you like. And so no one can stop you. So here, for example, if I want to sort of spare myself the, like, what digit does zeta see is somewhere in this box, I can just sort of fill this in. We're missing a 2, a 3, 4, 5, and a 6. And now the conflict checker very kindly points out this can only be a 5. This can only be a 2. So that's a 3 and that's a 5. And now these are a 3, 6 pair. Okay. Before we go too crazy with sort of pencil marking the entire grid, let's ask ourselves what these can be. Namely, these are 6 and 8. And in fact, actually, they're 6, 8, and we know the order, which is 6 there and 8 there. And so if I'm thinking about what can these be, I think they can still get away with being either 2, 7 or 4, 5, as best I can sort of tell. So I'm not quite sure about that yet. Let's see. Okay. So looking at that, what can this cell actually be? And so this is also a thing you can start asking once the grid gets filled in, is I've got this circle, I'm kind of interested. I know it's at least 3, but it's actually not 3. It's not 4. It's not 5. It's not 6. It's not 7. And it's not 9. So this circle is actually just an 8. It is nothing other than 8. And so that's very helpful because it means I know what this sum is. Because again, there's 3 possibilities for 8 in 2 cells. And you can sort of tick them off in your mind. They're 1, 7, 2, 6, and 3, 5. And this one can only be 1, 7 owing to the 3 and the 6 in the row. So it gives me a 1 here and a 7 here. It gives me a 6 and a 7 up there. It gives me a 3 and a 6 up there. And now that 7 actually tells me what the last arrow in the puzzle is. Namely, this now, the 4 ways to make 9, it's not 1, 8, it's not 2, 7, it's not 3, 6, so this has to be 4, 5. And so we can fill in the 5 and the 4, the 9 and the 5, the 2 and the 4, like that. One advantage, by the way, of sort of aggressively pencil marking if you're doing this is that sort of the last part of the puzzle, you just basically get to fill in almost everything. Okay, so let's do a little bit of Sudoku to sort of wrap this up, because at this point, you'll sort of notice this in various sorts of puzzles. At this point, we filled in all the clues, so we only have Sudoku left. And so let's ask ourselves, like, where does the 5 go in this box? The 5 has to go there. What is this digit? That digit is a 2. I'm just looking for rows, columns, and boxes that only have 1 digit left, so that digit's a 3. This digit's a 1 because the box needs a 1. And now let's see, what have I got over here? I need a 3, a 6, and a 9. And if I just fill them in, I can do that. 4, 2, 3. This is missing a 4. This is missing a 2. And this is missing a 7. There we go. Alrighty, well, I hope you enjoyed that. I hope you gave it a try. Let me know in the comments. But we'll be back soon with another episode of Introduction to Puzzles. I believe we post them Mondays, Wednesdays, and Fridays. So I look forward to seeing how people like them. But for now, bye-bye. Be back soon.